Alright, so 2.5 is zeros of polynomial functions. So what we're doing here is we're continuing on, because as you can see, zeros is something we've been looking at since we started chapter 2 for the most part. So 2.3, we're finding zeros basically by factoring. So we have polynomials that can factor. Then in 2.4, we are introduced to polynomial functions that don't factor, but they provide us with an initial zero so that we can do synthetic division and get our polynomial down to a quadratic in order to solve it. So obviously we're not going to always be given an initial zero. And so essentially what we're doing here is this section is going to teach us how to solve any type of polynomial function, no matter the degree. No matter if it's factorable. And so we have a process that we have to follow, right? So everything's about a process. So the first step in the process is that we are going to use the rational zero theorem to find all possible rational zeros. And so essentially we have this theorem, the rational zero theorem, and only thing that matters to you is what is called P over Q. All right. So essentially what we're looking for when we have the rational zero theorem is we're looking for what we call P over Q. In the rational zero theorem, the P represents the factors of the constant term, and Q represent factors of the leading coefficient. Okay, so given a polynomial, we are going to look for the list of possible zeros, right? So the directions will tell you use the rational zero theorem. So anytime you see rational zero theorem, your mind has to say P over Q, right? So this is the part where we have to connect the words to what to do. So we have to learn our vocabulary so that we can learn our process. So if we're looking for using the rational zero theorem, that means P over Q. And we're looking for all possible rational zeros. So we're just looking for all of the values, the integers and the fractions that could possibly be an actual zero of the polynomial is what we're doing. So P over Q. P is the constant term, so in this case 4. Q is the factors of the leading coefficient, so a 1. So 4, factors of 4, plus or minus 1, plus or minus 2, plus or minus 4. So one thing you have to do is that you're always going to do the plus or minus of the factors. So every factor, you must account for the positive factor and the negative factor, and then over plus or minus 1. And so then you just take that denominator and you just divide it out individually. So it would be plus or minus 1, plus or minus 2, and plus or minus 4. So all of my possible zeros, rational zeros for this function, are positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. So that's your list of all the possibles. So you can use the plus or minus button, or you can list them out separately with a comma. Alright, so that's what we're doing first. We're just using the rational zero theorem to be able to list all possible zeros. So let's look at another one. So 15x cubed plus 14x squared minus 3x minus 2. One thing we want to understand is that the entire function is irrelevant to me at this state in the problem. I am only using the rational zero theorem in order to find all possible rational zeros. What does that mean? That means all I care about is P over Q right now. So in this case, P is a negative 2. Here's what's important. The sign of the value P and Q are irrelevant. Why? Because we're listing factors, and the factors must always account for plus and minus. So P is 2, Q is 15. So when I do my factors of 2, they are plus or minus 1, plus or minus 2. Then I'm going to do my factors of 15, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So we want to make sure we remember factors, things that multiply to create the number, right? That's not a college algebra concept. That's a basic math concept. That's not an algebra concept at all, the word factors. So you need to make sure you understand that. If you don't know your timetables, use your calculator, right? You got to have your calculator as your friend. So I list my factors of 2. I list my factors of 15. But now we actually have to list them out separately. So what you should do is you should divide by each denominator into each numerator. So I'm going to show you what I mean. So I'm going to start with the 1. 1 into 1 gives me a 1. 1 into 2 gives me a 2. So I'm done with that one. Now I'm going to divide everything by the 3. So plus or minus 3 divided into 1. It doesn't divide evenly. So if it doesn't divide evenly, you just write the fraction. And then plus or minus 2 over 3. Alright, so that one's done. Next, the 5. The 5's not going to divide into them evenly, so I'm going to just write them as fractions. The top over the bottom. And then same thing for the last one, plus or minus 1/15, plus or minus 2/15. And that's it. So this is the list of all of the possible rational zeros for this particular polynomial function. So this is all of my list. And you can list them separately, positive 1, negative 1, positive 2, negative 2. But why do that when you can use plus or minus? Alright, so that's what we're doing with the rational zero theorem. You are identifying all of the possible zeros. What are all the values that could possibly be a zero to this function? Alright? Alright, so let's look at this problem. We are looking to use the rational zero theorem to find all the possible rational zeros of this function. F of x equals x cubed plus 7x squared plus 11x minus 3. So my p is 3. And my q is 1. Remember, the sign is irrelevant. If you write negative 3, it doesn't mean anything, right? You can write negative 3 if you want, because you're listing the factors of the 3. So writing the negative 3 doesn't mean anything. So when we list the factors, plus or minus 1, plus or minus 3, plus or minus 1. So the factors of this is just going to be, the possible factors are positive 1, negative 1, positive 3, negative 3. All right? So we're actually going to go ahead and we're going to go through the steps using this particular function. So we found the list of possible rational zeros. A positive 1, negative 1, positive 3, negative 3. So we're going to go to step 2. Step 2 says, use synthetic division to test possible zeros to find an actual initial zero. So what we need, like in 2.4, they provided us with an initial zero. And so we need to make sure we remember. Remember, the goal is to get the polynomial function down into a quadratic. Because if you have a polynomial that you can't factor, there's nothing that you already learned how to do in order to solve it until you get to the quadratic formula. And so this is the new material. We are learning how to be able to break polynomials down, get them into a quadratic so we can complete the solving process. So we are going to be able to identify an initial zero here by using these possible zeros. So what we have to do is we actually have to do a test. So we have to test the values. So you choose any number you want, right? So we're just going to choose positive 1. So we're going to test positive 1. We use 1 as our shelf because we're doing synthetic division, right? We have to know what the process names are. So that means 1, 7, 11, negative 3 go across the top. And we go through our synthetic division process. Here's what we want to think about from our previous section. How do I know if the 1 is an actual zero? So I'll know if the 1 is an actual zero if I get a 0 in the remainder spot. If I don't get a 0 in the remainder spot, then 1 is not a 0, and I have to try another number. So let's go through it. 1 times 1 is 1. 8. 8 times 1 is 8. 19. 19 times 1 is 19. So this clearly is not going to give me 0, which means 1 is not a 0. So I have to try another number. So let's go with negative 1. 1, 7, 11, negative 3. And so really it's just you testing until you get one that gives you the number you need. This doesn't give me the number I need. So then you try another one. I only got 2 options left, so 3 and negative 3. So one thing is that you won't get anything too outrageous, right? So you just have to really take your time and do your synthetic division. Don't be lazy about it. But usually the ones that we give you or that you'll see, it'll be a smaller number, right? The ones, the twos, the threes, both positive or negative. So make sure you try both of those types. So it's wonderful when we only have like 4 possibles, right? That's not that much. But if you have like 12 possible zeros, you don't want to sit there doing it for 12 different numbers, even though maybe you will have to sometimes in life. But basically for this class, you should be good. It should be like one of the smaller values. But again, it is what it is. You have to sit there and test. You got to sit there and test. Like, don't be lazy with it. Once you know your process, you know your process. All right, so let's try the -3. -3, 4, -12, -1, +3. I got a 0. Bam. So what does that mean? That means -3 is an initial 0 to this particular problem. So we are finding the zeros to this function. So we're looking for the zeros for this function. So I've already found 1 0 to this function. It's -3. So the third step says use the list and synthetic division to find actual zeros and get the polynomial down to a quadratic. So because this was an execute problem, once I found this initial 0 right here from step 2, I'm already at step 3 because I only needed to do this synthetic division one time. Because look, this is at a quadratic right now. This is already at a quadratic. So I'm really ready to solve. So because I don't need to do synthetic division again, this problem is at the quadratic form state, I can apply my quadratic formula so that I can finish and find all the zeros. So ABC. So remember, quadratic formula over 2a. So we're going to substitute those in. 4 squared AC. Alright, so -4 plus or minus 16 plus 4 over 2. -4 plus or minus 20 over 2. Alright, so here's where our prep assignment comes into play, right? So realize that most of the work that we're doing on this problem, once we do our synthetic division, our work is essentially prerequisite work. Quadratic formula, factoring, stuff like that. So I'm going to simplify this. Square root of 20. 4, 5, 2, 2. So when I simplify that, I get 4 plus or minus 2 square root of 5 all over 2. Remember, you have to reduce the lowest terms. So this reduces to -2 plus or minus square root of 5. And so what are the zeros for this particular problem? The zeros for this particular problem were -3, -2 plus square root of 5, -2 minus square root of 5. My math lab does have the plus or minus button, so you don't have to separate them, right? And when you do it for me, or when you do it on your test or final, you would always just do plus or minus, which is perfectly fine, which is how I wrote it down there. All right, but you just want to make sure that all of the zeros, so you have to make sure you bring in that initial 0 that we found in the beginning. And so that's going through all the steps to solve and find the zeros of the polynomial function. So you use the rational zero theorem, do your P over Q, you get a list. Then you're going to go through that list using synthetic division until you find one that is actually a 0. And once you find that 0, you're good to go. And you just keep doing that same process until you get the polynomial down to a quadratic. So like if it was a 4th degree, we would have had to do an initial 0. We would have had to test numbers at least 2 times in order to get it down to a quadratic, right? And so that's what you're doing. You just keep finding zeros by doing synthetic division until you get the polynomial down into a quadratic form, and then you can try to factor it or do the quadratic formula. All right, let's do another one. All right, so here we're going through the steps to identify the zeros of the polynomial function. So our directions for this particular problem tell us to just solve it. So remember from the previous section when I told you that if they tell you find the zeros, it'll be in the f of x format. If they tell you to solve, it'll already be equal to 0. But the process isn't different, okay? So first we have to identify all the possible rational zeros for this particular function. And so what does that mean? That means we're looking for P over Q. So P over Q would be 8 over 1. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over plus or minus 1. So all of our possible zeros are as follows. And so what does that mean for us? That means that we have to sit here and we have to test. All right, so my recommendation to you is to always try your 1s and your 2s and your 3s. All right, so I'm gonna go with 1. So let's test. So 1 is my shelf. 1, -3, -20, -24, -8. So we got to go through synthetic division. And we know it's correct if we end up with 0 as the remainder. -2, -2, -22, -22. So this is no way going to do what I need it to do for me, right? Because this is the -46. So that's out. All right, let's try -1. 1, -3, -20, -24, -8. So -1, -4, 4, -16, 16, -8, 8, 0. Yes. All right, so we got -1. Now, we are at step 2. We just use synthetic division to test possible zeros to find an actual initial zero. So we found an initial 0. This is a 4th degree polynomial, okay? And so this is how you can help yourself know what to do before you even start the problem. 4th degree means I would have to divide this polynomial out twice before it could get down to quadratic. What does that mean to you? It means that you should have to find 2 rational zeros by doing synthetic division before you'll be able to get it down to use the quadratic formula or factor the problem. So if you look, I have 1, -4, -16, and -8. Remember from the previous section I told you, you'll always know when you're ready for quadratic because what will you have? ABC. I don't have ABC. Look at this. I still got a -8 sitting there, which means I'm not ready for quadratic form yet. So I'm not done. I'm on step 3 now. So step 3 says, use the list of possible zeros and your synthetic division to find actual zeros and get the polynomial to a quadratic, which means I have to keep testing. So I have to keep testing from my list of possible zeros until I can get this down to a quadratic. So right now I'm at a cube, right? Because I've divided 1 time from the 4th, so I'm at a cubed. So now I need to test some more. So let's test the 2. Another important mark for you to understand, you do not go back to the original polynomial when you start testing a new actual zero. So because if I go back to the original, I'm starting back at a 4th degree. So you should use your answer from the one that gave you a 0. All right, -4, -20, this is not gonna work. All right, let's try -2. So 1, -4, -16, -8, -6, 12, -4, 8. Got it. So now when I look, what am I? A, B, C. I'm good. Now I'm at my quadratic state. And so now I can stop using synthetic division. I don't need to test any more actual zeros, any more possible zeros. I'm sorry. And then I can do my quadratic formula at this point, or I could see if it's factorable. All right. But this one's not factorable, so. All right, so I'm already at 2 zeros. So I know that x is -1 and I know x is -2. So now I'm gonna find my other zeros. So x equals, and I'm doing my quadratic formula. Yes, it will be given to you on the final exam, but you should have it learned, honestly. 4ac all over 2a. All right, plus or minus 36 plus 16 over 2, 6 plus or minus 52 over 2. So we have to break down that 52. So 2 times 26, 2 times 13. So I have a pair of 2's in there. So 6 plus or minus 2 square root of 13 over 2. So how does that simplify? Remember, 6, 2, and 2, they must all share a common factor. So 3 plus or minus 1 square root of 13. But you don't have to put the 1, right? So that would be 3 plus or minus square root of 13 would be my other two zeros. Remember, that's the same as 3 plus square root of 13, same thing as 3 minus square root of 13. And so we have solved this polynomial function, or we have found the zeros of the polynomial function, right? Either way, directions mean the same thing. And so we had a fourth degree. So starting at a fourth degree, you'll know you need to do synthetic division with possible rational zeros twice until you get to the quadratic form. If it was an x to the fifth degree, we know we'd have to do synthetic division and find rational zeros 3 times before we get down to the quadratic, right? So it's just an ongoing process for you. All right, so that's 2.5.